So here is the way for ligating the DNA, which is broken down, means broken because of any uncertainty happened in the cell. So to ligate it, DNA ligase come and join these two, as it have that catalytic property. But this process is a bit inferior to the homologous AND joining. This non-homologous AND joining is a bit inferior to the homologous AND joining because of a plus point for the homologous one, that it is not the error prone. This one is error prone, means some errors can occur while ligating these two strands. Some of the extra can be added, means because this ligase doesn't know which one is adding, or it does, the only work it need to done is the ligating the two strands. Okay, means that hydrolysis property, it has that hydrolysis property only. It doesn't know whether which is coming in extra or whether something is missing out or not. So it doesn't have any checking property or checking security in it. But in the same way, this person is telling me that in this homology directed repair, here this strand get, means first of all what happened, let me explain it to you more clearly, that this is an enzyme which is known as REC-BCD. This does the resection of the DNA up to the chi site. He says it chi site. That chi site stands for GCT, GGT, GG. This chi site, it resects the DNA up to the chi site, and then its work is being over. After that, what comes into play is this procedure, that this strand come up to here. This is the homologous DNA being present, means there is a pair of homology in our genome. So here this is the strand coming up here, and then DNA polymerase will make it up to which it is needed. Still, here is a question, that how this DNA polymerase will get to know that where to stop, means it will get to make this DNA, to polymerize this DNA as much as long needed. But how will it get to know that it need to stop over here? It need to stop over here so that it can ligate here, right? This is the main question. Then after that, I have one more question, that after this DNA polymerization, this DNA comes over here, and after this polymerization, when this ligate at this same time, when the non-homologous directed repair was occurring, the DNA ligase was working, right? And that DNA ligase was having the error prone. Same time here, the DNA ligase is working, and the question is, why not it is being prone over here? The only plus point of this procedure is the error prone decrement, right? So if it doesn't have that decrement over here, then why it is preferred over the non-homology directed repair? That's the main question.